We'll continue with our discussion on confidence interval. So we talked about confidence interval for population proportion, and we have defined the confidence interval, the formula, we found it, and then we talked about three different examples of confidence interval. Now I'm going to give you 4 more examples, so a total of 7 examples, okay? So for confidence interval for population proportion, we're going to have 7 examples. So the reason I'm giving you a lot of examples is to ensure that you are okay with the process. Once you get comfortable with the process for one of them, the rest of the topics on confidence interval and hypothesis testing are going to be quite easy. All right. Okay, so this problem, example, regular marijuana users in the long run experience memory loss. As a researcher, you would like to know what percentage of marijuana users experience memory loss. So you gave memory test to 30 marijuana users and found that 7 of them had memory loss. Create 97% confidence interval for the population proportion of marijuana users that experience memory loss, okay? So, you know that people who use marijuana on a regular basis, they experience memory loss. Basically, you want to find out what percentage of those marijuana users actually experience memory loss. That's what you're trying to do. Okay, repeated marijuana usage causes your memory to be weaker, and you want to find out what percentage of repeated or regular marijuana users experience that kind of memory loss. And to do that, you surveyed 30 people, and out of those, or you gave test to 30 people and found that 7 of them had problem with their memory. So let's collect the information. Your sample size n is equal to 30 because you gave the memory test to 30 people, and your x, people with memory problems, was 7. So your p hat is going to be x over n, which is 7 over 30, right? Which is, by the way, approximately 0.23, I believe. Okay, so let me just double check to make sure. 7 divided by 30 is 0.2333. So I round it to 0.23. So your p hat is approximately equal to 0.23. Then the problem wants you to find 97% confidence interval. So your confidence level is going to be 97%, which is 0.97. Your significance level alpha is 1 minus the confidence level, that is 1 minus 0.97, right? So that is going to give you alpha is equal to 0.03. Or we need to divide it into 2 tails. So alpha over 2 is 0.03 divided by 2, which is 0.015. So alpha over 2 is equal to 0.015. Okay. So alpha over 2 is 0.015. Now let me go ahead and create that diagram for standard normal distribution. So there's going to be standard normal distribution, mean 0, standard deviation 1, and your area to the left tail is going to be 0.015, 0.015, and area to the right tail is 0.015. Okay. Now, associated with the area of 0.015, there should be a z-score, and you need to find that z-score. Everybody, please go ahead and find that. Associated with 0.015, what is the z-score? It's important for you to know how to do this. By now, you should be very proficient in finding these values. So 0.015, what Z value does it give you? Remember, 0.015 is the probability. So sometimes you are given the Z score, and actually most of the times you are given the Z scores, and from that you find the probability. However, sometimes you're given the probability, and from that you need to find the Z score. And in this case, in this particular example, you're given the probability. Remember, whenever you are given area, you are actually given the probability. So if the probability is given, what is the Z score? So somebody, not somebody, everybody should be looking at it, and please tell me, what is the Z score for this? It is negative 2.17. Okay, thank you. It is negative 2.17, and that is your negative Z sub alpha over 2 is 0.015. And by symmetry, the right side is going to be 2.17, and that is Z sub 0.015. Now that I know my Z value, I have everything that I need in order to calculate my confidence interval. So look, confidence interval is P hat plus or minus margin of error, where margin of error E is equal to Z sub alpha over 2 times square root of P hat times 1 minus P hat, all of it divided by the sample size N. So our E, or margin of error, is equal to Z sub alpha over 2 times square root of P hat times 1 minus P hat, all of it divided by the sample size N. So my Z sub alpha over 2 is 2.17, right? Times square root of P hat. P hat is P hat is 0.23, right? So 0.23 times 1 minus 0.23, which is going to be 0.77, by the way. All of it divided by the sample size N, which was 30. So if I do the math, what do I get? So 0.23 times 0.77 divided by 30, square root of it, times 2.17, that is going to be 0.1667. 0.1667. So I'm going to round it to, by the way, 0.17. Okay, 100th place. E is equal to approximately 0.17. 0.17. So your margin of error is approximately 0.17. So your confidence interval is going to be P hat plus or minus E, which is going to be equal to P hat is 0.23 plus or minus margin of error is 0.17, right? So that's going to give you 0.23 minus 0.17, comma 0.23 plus 0.17. So 0.23 minus 0.17 is 0.06, comma 0.23 plus 17 is 0.30, 0.40. 0.40, which is to say your confidence interval falls between 6% and what? 40%. And how confident are you in your calculation? It's 97% confidence, or 0.97, right? So there is a 97% probability that your confidence, your proportion falls inside this interval. I kind of said it in the wrong way, not 97% probability. You have 97% confidence level that, or you have 97% confidence that the actual population proportion of marijuana users who experience memory loss falls between 6% and 40%. And I already have said it many, many times. So Let me say it again. 97% confidence means that if you were to create many samples, take many samples of size 30 and create a confidence interval from each of these samples, then about 97% of those confidence intervals will include the true population proportion, whereas 3% will not. So if you made, let's say, 1 million confidence intervals, so approximately 97% of that, which is 970K, will include population proportion, okay? Include population proportion, whereas about 3% of that, or which is 30K, will not include population proportion. All right? That is what it is. So this is how you do this problem. So now, any question, anybody on this problem? Any part of the problem? Are you having difficulties understanding or have any questions about anybody? All right, in that case, I'm gonna want you to do the next problem, okay? According to a recent Pew research, among the married or cohabiting couples in the US, about a third of them have women who earn equal or more in the household. So among the cohabiting couples, about 33% or a third of them have spouse who make more than the other spouse. That means the female spouse make more than the male spouse. Okay, so 33% or a third of them make in the household, women make more than or equal to men do. So you kind of want to test it. So what you did, you surveyed 100 people, okay, and found that in your city, you did the survey, okay, found that 22 of them said that women bring in equal or more. Based on this information, can you either reject or fail to reject the Pew Research's new claim that with 95% confidence? All right. So simply speaking, Pew Research says that about a third of the household has women either earn equal or more than the man. Okay, third of the households, you can think of it that way. Now you wanted to test it and you went into, let's say, your city, and you collected data from 100 couples and found that among those couples, 22 of them where women make more money than the men do, okay, or equal to. So now based on this, you need to create a 95% confidence interval. So just write down the pieces of information. N is the sample size, which is 100. X is the number you got out of 100, number of households where women make equal or more than the men. So your P hat is going to be X over N, that is 22 over 100, that is 0.22. P hat is 0.22. And confidence level, they told you, is 95% confidence, 95%, which is equal to 0.95. And then significance level alpha is going to be 1 minus the confidence level. That is alpha is equal to 1 minus 0.95, that is 0.05. So alpha over 2 is going to be 0.05 divided by 2, which is 0.025. So alpha over 2 is 0.025. Now we go ahead and create our diagram that will help us see things. So standard normal distribution table, which is 0 and 1. Okay. 0.025, 0.025, right tail and left tail. Each tail is alpha over 2. Now associated with 0.025, there is a z-score. And what is that z-score you guys found?
Negative 1.96.
Negative 1, thank you, negative 1.96. That is negative z sub 0.025. And by symmetry, the right side is going to be positive 1.96, which is z sub 0.025. Now that you have these values, you can easily calculate the margin of error. Margin of error E is z sub alpha over 2 times square root of p hat times 1 minus p hat, all of it divided by the sample size n, or margin of error E is equal to z sub alpha over 2, 1.96 times square root of p hat is 0.22, right? 1 minus 0.22 is 0.78, by the way. All of it divided by the sample size, which is 100. If you did the calculation properly, it's going to be 0.22 times 0.78 divided by 100, square root of it, 1.96 is 0.0811. So margin of error is 0.0811, and I round it to approximately 0.08. All right. So your confidence interval is going to be CI is going to be p hat plus or minus the margin of error. So p hat is 0.22, okay, plus or minus 0.08. That is going to be equal to 0.22 minus 0.08, comma 0.22 plus 0.08. All right, that is going to give you 0.22 minus 0.08 is 0.14, comma 0.22 plus 0.08 is 0.30, which is, by the way, between 14% and 30%. And your confidence level is 95%, right? So you have 95% confidence that the true population proportion for married couples among whom women make more than or equal to the man falls between 14 and 30%. So that proportion of families, okay, compared to all the couples where women make more than or equal to men is between 14 and 30%. However, the national survey gave you a third, right? Which is approximately 33.33%, right? It's approximately 33.33%. This 33.33%, however, does not fall within this window, okay, or within this interval, confidence interval that you have created. This 33.33% does not fall within this confidence interval that you have created. So therefore, you would probably say that based on your calculation, the folks in your city have a lower percentage compared to the national average, national percentage or proportion. So this is what the moral of the story here is. By the way, you cannot say that, oh, based on my calculation, I'm going to reject the Pew Research's conclusion. You are just comparing the national trend with your city's trend, okay? Because your sample does not represent the probably national population. It's very local. It's true for your city. So that's what you want to find out, okay? So this kind of study could be important for policy making, like, when policymakers make policies, they can look at comparative data or comparative analysis of data, national versus local, and then shape policies in a way so that it benefits the local community. So statistics is a subject is very, very useful in many, many fields, okay? Anything under the sun or in the universe, you could apply statistics to pretty much. So, excuse me. So anyway, is this okay, everyone? Any question from anybody? No questions? Everybody okay? Great. So in this problem, what do we have? According to Pew Research, in 2017, 67% of the Muslim Americans believe that blacks should be given equal rights with the whites compared to 57% in the population. To test this new claim, you surveyed 100 Muslim Americans, including your teacher, and found that 70 believed that the blacks need equal rights. Can you reject Pew Research's new claim with 85% confidence level? So Pew Research is saying that, 67% of the Muslim Americans believe that blacks should be given equal rights with the whites. You just want to test that claim. All right. So you went out and surveyed 100 people and 100 Muslim Americans, and 70 of them said yes, they should. We should give equal rights to black and whites. Okay. Can you reject the Pew Research's new claim with 85% confidence level? Okay. So 85% confidence level. So let's pick the numbers. Sample size n is equal to 100, x is equal to 70. So p hat is going to be x over n, which is 70 over 100, which is just 0.7. Your p hat is 0.7. Now your confidence level is 95% or 85%. 85%, that is, by the way, 0.85. And significance level alpha is 1 minus 0.85, or 1 minus the confidence level, which is 0.15. So alpha over 2 is going to be 0.15 divided by 2, which is 0.075. So alpha over 2 is 0.075. All right. Now let's go ahead and draw the diagram for standard normal distribution. Mu is equal to 0 and sigma is equal to 1, and area to the left is going to be 0.075, and area to the right tail is going to be 0.075. So your margin of error, E, is going to be Z sub alpha over 2 times square root of P hat times 1 minus P hat, all of it divided by the sample size n. So now associated with 0.075, what Z value did you get? What is the Z value?
Negative 1.44.
Negative 1.44. That sounds about right. Negative 1.44, which is your negative Z sub 0.075. And by symmetry, this is going to be 1.44. It's a mirror image, which is going to be Z sub 0.075. Now we can just do this calculation very easily. Z sub alpha over 2 is going to be 1.44 times square root of p hat. P hat is 0.7 times 1 minus p hat is 1 minus 0.7. That's going to be 0.3. All of it divided by the sample size of 100. And that should give you 0.7 times 0.3 divided by 100. Square root of it times 1.44. 0.0659. 0.0659, which is approximately 0.07. So your margin of error is approximately 0.07. Now your confidence interval is going to be p hat plus or minus your margin of error, which is p hat is 0.70 plus or minus 0.07. That is going to be equal to 0.70 minus 0.07, comma 0.70 plus 0.07. If you simplify it, is going to be 0.63, comma 0.77, which is between 63% and 77%. That's between 63% and 77%. So now you are 85% confident, 85% confident that actual percentage of Muslim Americans who believe in equal rights for black and women, black and white, falls between 63% and 77%. However, what is it that the Pew Research found? 67%. Okay, so let's take 67%. 67% obviously does fall within this confidence interval. So therefore, you would say, yes, you probably would agree with Pew Research's conclusion that 67% of the Muslim Americans believe in equal rights, because that 67% does in fact fall within the window or within the interval that you have created. The confidence interval 63 to 67 does in fact include 67%. And also from this you can conclude that you probably have taken the data locally. So that means that you kind of could say that, oh, okay, and the proportion is actually the same in our community as it is in the entire nation. So that's how I talk about it. And now let's go ahead and work on the next problem. So in this problem, again, according to Pew Research, in 2016, 63% of the Americans said that homosexuality should be accepted by the society, compared to 51% in 2006. Okay, 63% of the people in 2016 said that homosexuality.
You shut this one then.
You said I'm gone. I didn't leave. It kicked me out for some reason. Boy, I'm trying.
Hey, Kayla, I think
You're
Okay. So 63% of the Americans said that homosexuality should be accepted by the society. In 2006, that proportion was 51%. So now you kind of wanted to compare the situation in your city, with that of the national trend, kind of. So you surveyed 100 people, and 55 of them said that the society should accept homosexuality. Now, based on that, can you kind of reject Pew's conclusion or don't reject? Okay. So your sample size n is equal to 100. Your x is equal to 55. So p hat is equal to x over n, that is 55 over 100, that is 0.55. So p hat is equal to 0.55. So next, your confidence level is given to be 90%, which is 0.90. Your significance level alpha is 1 minus the confidence level, that is 1 minus 0.90. That is going to give you alpha is equal to 0.10. Now alpha over 2 is going to be 0.10 divided by 2. That gives you alpha over 2 is 0.05. Now let's go ahead and do the standard normal distribution diagram. Mu 0, sigma 1, and area to the left tail should be 0.05, and area to the right tail should be 0.05. Now this is a very special value. By now you should probably get used to. If the area to the left is 0.05, okay, that corresponds to z-score of negative 1.645. Okay, if area is 0.025, that corresponds to negative 1.96. So please remember these two values. Okay, 0.05 and 0.25. These are special values. So this is negative 1.645. That is the same as negative z sub 0.05. And by symmetry, the right side is going to be 1.645, and that is z sub 0.05. So now that I have the z values, I can go ahead and find the margin of error, which is z sub alpha over 2 times square root of p hat times 1 minus p hat, all of it divided by the sample size n. So 1.645 times p hat is 0.55, right? 0.55 times 1 minus p hat is 1 minus 0.55, which is 0.45, divided by the sample size, which is 100. Now, if you do the calculation, 0.55 times 0.45 divided by 100, take the square root of it and multiply it by 1.645, it's 0.0818, which is 0.0818, which we can round to approximately 0.08. All right. So now your confidence interval is going to be for p hat plus or minus margin of error, that is 0.55 plus or minus 0.08. That is to say 0.55 minus 0.08, comma, 0.55 plus 0.08. And that is going to be 0.55 minus 0.08 is 0.47, comma, 0.55 plus 0.08, 0.63. That is going to be between 47% and 63%. Now that's what your calculation gives you for confidence interval. And how confident are you? 90%, which is 0.90. Now, what did the Pew Research say? 63%. Now, 63%, the national proportion is 63%. Now, my question to you guys, is 63% in this interval? Is the 63% in this interval, guys?
Yes.
Yes, okay. Anybody else thinks differently? Okay, so here is something I kind of want to tell you. So let's say I say 1,3, right? 1,3. Is 3 in this interval? The answer is actually no. What does this open interval 1,3 means? 0, 1, 2, 3, 4, 5, etc., right? So what this means is this. You are considering all the points between 1 and 3, okay, except the boundary points 1 and 3. So 1 and 3 are not included here. So 1 and 3 are not included. It's everything in between 1 and 3. So similarly, 63% is actually not included in this interval. So based on your calculation, you could say probably, you know, this is a borderline case, okay? This is a borderline case because the point is right there. So you could say that probably proportion is slightly lower in your community than the national proportion, okay? People, those who believe that homosexuality should be accepted, okay? The percentage of those people in your city is probably slightly less than the percentage in the national, nationwide, okay, or in the national environment or whatever. Does it make sense, guys? Okay. Any question, anybody? If that is the case, that concludes everything that we wanted to talk about for confidence interval. I have given 7 examples, not 1 or not 2 or not 3 or 4, even 7 different examples for you to be able to understand this concept. So I have done each of these problems in the class, and I went through this step by step to ensure that you understand. Okay, and now you have to practice it on your own a little bit to get a good feel for it. All right. Previously, I said that we are going to do confidence interval for proportion, mean, and standard deviation. So we did it for proportion. Now you're going to do it for mean. Mean has 2 scenarios: when you know sigma or when you do not know sigma. Mean has 2 scenarios: when you know sigma or when you do not know sigma. All right. When you know sigma, you use the z-scores formula. Okay, z-scores like the ones we have been using. When you do not know, however, you use student distribution. You use student distribution. When you know sigma, you use z-scores. When you don't, you use student distribution. So tonight we're going to talk about this, but this one we'll talk about it on Wednesday. So when you know sigma, this is the case. You know sigma right here. Look at it here. Okay. You know sigma. In that case, your confidence interval becomes X bar. Remember, we are not doing for P anymore. We are doing for mu, population mean. And X bar plus or minus margin of error. And the calculation here is much easier, which is just Z sub alpha over 2, which you know already how to find, times sigma divided by square root of the sample size. That's it. It's that simple. Now, let's go ahead and do this problem here. According to USA Today College, an American college student studies about 17 hours per week with population standard deviation 4. So that means you're given sigma. That give you sigma, which is 4, population standard deviation. You would like to know if a similar trend is present at your school. So you surveyed 100 students and found that their average is 15 hours. This 15 hours, you have to remember, that's X bar. And this 17 hours that you have to remember, that's mu. So these two numbers people get confused with. Create a 99% confidence interval for the population average for your college. Okay, so let's go ahead and do the problem. So I'm gonna go ahead and create the diagram. So let's collect the data points. Sample size n is equal to 100. Okay, your X bar sample mean was 15. Okay, and what else I need? Alpha was 99%. Alpha was 1 minus confidence level, which is 1 minus 0.99, which is 0.01. So alpha over 2 is going to be 0.01 divided by 2, which is 0.005. So alpha over 2 is 0.005. So area to the left is going to be 0.005, and the area to the right, or right tail, is going to be 0.005. So this point and this point you need to find. So can somebody look it up in the table and give me this number, that to the left one? Negative 2.575. That is correct. Thank you. Negative 2.575. That's your Z sub 0.005. And similarly, by symmetry, 2.575. That's going to be your Z sub 0.005. Now you just do the margin of error calculation, right? So let's do the margin of error. E is equal to Z sub alpha over 2 times sigma divided by the square root of the sample size. This is really an easy problem. 2.575 times sigma is 4 divided by square root of what? 100. Sample size is 100. So that's gonna give you, if you do the simplification, 4 divided by 100 is 4 divided by 10, which is 0.4. 0.4 times 2.575 is 1.03. 1.03. So E is equal to 1.03. So your confidence interval is going to be X bar plus or minus margin of error, or X bar is 15, right? X bar 15, which is the number that was given to you, plus or minus margin of error 1.03. So if you write it out, it is going to be 15 minus 1.03, comma 15 plus 1.03. That is going to give you, what is it you're going to get? 13.97, comma 16.03. So you're 99% confident, 99% confident that your actual average for the college would fall between 13.97 and 16.03. Based on this, since the national average they're saying is 17 hours per week, based on your calculation, you kind of would disagree with the national average. But then again, if you take a local perspective, your data, if your data happens to be representing the national population, then yes, you could say that we're going to reject the Pew Research's conclusion, okay, at 99% confidence level. On the other hand, if your data is local, you could say that your population probably, your student body probably studies little less than the national average, okay? And how confident are you in this calculation? You're 99, was it 99%? Yes, 99% confident. Okay, so your confidence level is 99%. And that is how you will do these problems, okay? And now that you have done one case in detail on the population proportion confidence interval, or confidence interval for population proportion, we have done it in detail. So everything else should be pretty much straightforward, easier, and kind of like following the same process. And same for hypothesis testing as well. All right. Once you understood this, you're okay. Rest of the semester is going to be rather not quite easy, but reasonably easy. I would say even quite easy, because we don't have any of the more difficult topics anymore. We talked about them, like the Bayes theorem. We talked about the central limit theorem and the sampling distribution and all those things. We already put them behind. We went over those. Now going forward, the materials are going to be much easier compared to Bayes theorem or central limit theorem stuff, okay? And this is pretty methodical. You follow a process and you will come up with the answer. And underneath all of this is actually the central limit theorem that we talked about. All of these calculations that we are doing is deriving from, or it is derived from, the central limit theorem. But the process for doing so is kind of like beyond the scope of this class. It requires a lot of math, I guess. And then in some cases, calculus too. So pretty much we covered the central limit theorem. And if you have a solid understanding of that, you can take that concept and apply it to different areas. Like confidence interval and hypothesis testing for population proportion and population mean, and etc. All right, enough of it for the day. Thank you so very much, folks. You have a wonderful evening, and I'll talk to you on Wednesday. Thank you.